All right, welcome back, ladies and gentlemen. These were the two problems you were supposed to do on your own. Number one, remember, we are going to factor everything, and then we are going to cancel what we can. Now, notice in number one, everything has been factored already. These are factored for us. So all we need to do is cancel. Notice that there is an x plus 1 in both the numerator and the denominator. So this cancels down to 2 over x plus 3. And that's my final answer. Number two, we need to factor everything. So this is what multiplies to be negative 3 and adds to be 2. That's x minus 3 and x plus 1. And the denominator is multiplies to be negative 6 and adds to be negative 1. That's x minus 3 and x plus 2. Everything has been factored, and I notice that there's an x minus 3 in both the numerator and the denominator. And now we see our final simplified answer, x plus 1 divided by x plus 2. All right, again, if you're having any problems with those, make sure you get your questions asked. The last two videos here, you've got to be able to do this simplifying step. So make sure you understand it before you move on. But let's go ahead and go and look at the next thing, which is multiplying. So when we multiply rational expressions together, we're really doing the same thing, but we're going to add a step. Okay? So number one, factor everything, right? You're going to see a common theme here. Factor everything all the time. Okay? And then we're going to multiply the fractions, right? Remember, multiplying fractions means multiply across. And then for the third part, again, we're going to divide out or cancel any of the common terms. Okay, so let's go ahead and look at an example. Here we have this rational expression times this rational expression. Notice that there is a lot of factoring to do, right? We've got to factor a lot here. So this top left, this is an x squared and an x term. That's not going to factor the, this times this. Or this, what multiplies to be this and adds to be this. So I do notice, however, that there is a 3x in both terms. And so I can factor out a 3x, leaving 1 minus x. And then in the denominator here, I got x plus 5 and x minus 1, right? That's going to be a negative 5 and adds to be positive 4. And that's times x squared plus x minus 20. So that's going to be an x plus 5 and an x minus 4. And then at the bottom here we have 3x. Okay, so I factored everything. Now I want to multiply across, right? Multiply across numerator to numerator, denominator to denominator. Now I'm going to fix this one right here. 1 minus x. I want the x to be first, so I'm going to rewrite it when I write it down here. I can move this to the front, right? And then it would be negative x plus 1. And if I run it through with a negative, I can call that x minus 1. Like these are the same thing. So, and then that's x plus 5, and that's x minus 4. And then in the denominator, I've got x plus 5 times x minus 1 times 3x. Notice how when we multiply these together, I'm just writing them out, right? Like I'm not actually foiling it. I'm writing it like this so that I can cancel it at the end, right? Look, there's x minus 1s that can cancel. There's x plus 5s that it can cancel, and there's 3x's that can cancel. So our final answer here is just x minus 4. Because when we multiply them together and write it out, we have a bunch of terms that cancel. This is why you always factor everything, right? Factor everything. We're always going to factor everything because everything is easier when we factor it, okay? I've got a sample for you to do back on your canvas. Go ahead and check that out, and then we'll see you in the next video.